This video is going to look at identifying our three key terms in studying motion or describing motion. And those, as you can see, are position, velocity, and acceleration. We'll also end up defining a bunch of other terms that are kind of related or adjacent. And as we bring those up, take note of those as well. So before we get into that, we want to talk about kinematics. And kinematics is the study of motion. So this is an important definition for you to keep in mind because we're going to use this word a lot throughout the unit. And kind of for the rest of this video and the rest of this unit, I'm going to use this word. And all that we're doing is talking about studying how things move and how we describe them and how we make predictions about motion. So the first term that we're going to talk about is position, and this is a specific location in space. That's our definition, a specific location in space. And sometimes you'll see and time. We're not going to worry about that for this unit. For now, we're just going to talk about a specific location in space. It's represented typically, and in this class, with the variable x. And the measurement or the units that we use are in meters. So we measure positions with x and we indicate them as meters because technically what we're saying is how far away from the 0 point is this object. It's 6 meters away from the, the origin or whatever. There are some related concepts to position that we're going to talk about here. So first of all, you have displacement, and this is a change in position, and we represent that with a delta x, and so this is the Greek letter delta, and it just means change in. And the way we calculate that is we take the final position and we subtract the initial position. So this x is the final position, and this x naught or x0 is the initial position. And that's standard notation we're going to see going forward. So anytime you see a delta, that means change. And anytime you see a delta, you know it's always a final of whatever the delta is minus the initial of whatever the delta is. And for initial, we put this 0, or sometimes this is a bit more of a Britishism or a Canadianism to say naught instead of 0. So that's laying some stuff that's going to come up in later steps as well. Total distance is, imagine laying down a string along the path and measuring. So the classic example to distinguish between these two, if I started at this point here, I travel over to here. So I started here, I traveled over to here, and then I came back to where I started. My displacement is 0 because the final position and the initial position are the same. But my distance is however long from here to here and then back from here to here. So the displacement is 0, but the distance is, imagine laying a string here and measuring it. Or if I tell you this is 5 meters between these two, the distance traveled would be 10 meters. Next, we're going to look at velocity. This is the rate of change of position with respect to time. So we're looking at how quickly I'm changing position in a given second or a given minute or a given hour, whatever that is. Typically, we represent that with the variable v, and we use the units of meters per second, which you'll sometimes also see presented like so, m divided by s, m over s. We calculate the velocity, or the velocity. We actually calculate average velocity as delta x over delta t. And so this right here, we call, or we say v bar, or you can say average velocity. Average velocity. and it equals the change in position over change in time. And this is what you've always probably learned before about speed, change in position over change in time, or distance divided by time. But I want to point out this is average velocity. Those of you that will take calculus or further physics classes will talk about instantaneous velocity as exactly what's going on at that point. But for now, we're just starting with average velocity. There are some related concepts, and that is speed. So velocity, because we're looking at a change in position over a change in time, velocity is a vector quantity. You can have, let me just rewrite that completely, quantity. You can have 30 meters per second in that direction, or 30 meters per second in that direction, or 10 meters per second north, or 10 meters per second south. That makes sense. Like, we can think about that like a speed and direction. That makes sense. You can describe those things. Speed is a scalar, just the magnitude. So if I tell you I'm moving 10 meters per second, I've given you my speed. I have not given you my velocity. If you want velocity, you're going to have to ask me which direction. So likewise, if you're asked to present a velocity, like at the end of a problem, you say, what's the velocity of this object? You need to say 10 meters per second and then give a direction. That can be in the positive direction. That can be something like east. That can be something like up, but it needs a direction. Popping back a slide real quick. Position, just a measurement of position. I want to make sure we reiterate this. That's a scalar. A position is just a number. It doesn't have direction associated with it. Displacement and total distance are both, displacement is a vector. I can move 5 meters to the right, or I can have moved 5 meters to the left. Those are different. Total distance is a scalar, because obviously we can't have direction here, because if we did, that would involve, left and right, and that's not a direction, that's two directions. These distinguishing things are going to be a lot of what we work through going through the rest of this unit, so if it doesn't all click in place, don't stress too much. Ask any questions you have, but also feel free to kind of jump into practice problems. Lastly, we have, whoops, I missed one. Average velocity. Oh, I already explained that up here. So I'll just bring that down here. Acceleration, the rate of change of velocity with respect to time. So what what velocity is to position, acceleration is to velocity, if you want to do your SAT analogies here. So it's represented with the letter A, the variable A, and it uses meters per second squared as our units typically. Another way you might see that is meters on top of a seconds squared. This is calculated by, again, I'm going to do the average acceleration, the change in velocity over the change in time. If you want to find the exact acceleration or the exact velocity, you need to take increasingly smaller changes in the velocity and time until you've got it really, 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 really tiny. There's a concept in math called the derivative, and that's what we use for this. But for this class, we can just worry about these averages being good enough. A related concept, like I said, we have average acceleration right here. So that will be our kind of core ideas. We're really just introducing the language, talking about a few things, and kind of moving forward. The last thing I do want to point out with acceleration, notice that this is a change of velocity with respect to time. It doesn't mean slowing down, it doesn't mean speeding up, it just means your velocity is changing. So we can say an object that, and we do say in physics, an object that is slowing down is experiencing acceleration. It is proper, though sometimes a bit weird, to say the object is accelerating as it slows down. If you prefer, you can say accelerate and decelerate. But generally speaking, how we're going to talk about it here is just, is the object accelerating or not? And the answer, if it's changing velocity, yes.